안녕하십니까. 세 번째 K 브랜드 엑스포 세미나를 시작해 보려고 합니다. 오늘 8시에 진행하는 이번 미팅의 세미나는 미국에서 굉장히 유명한 대학교죠. 노틀담 대학교의 죄송합니다. 제가 지금 파일을 켜놓고서 안 보고 이 얘기를 하고 있네요. 닥터 그레엄 피슬리라는 분인데요. 노틀담 대학교의 물리학 교수십니다. 이번에 북미 대륙에 불소화합물이 첨가된 또는 불소화합물에 관련된 화장품에 대해서 강의를 해주실 겁니다. 오늘 죄송합니다만 저희가 너무 어려운 내용을 민감한 부분이어서 저희가 통역을 준비했다가 동시 통역을 하지 못하게 되었습니다. 이 파일을 너무 늦게 받아서 저희가 동시 통역을 해드리지 못하고 오늘은 이 미팅이 영어로 진행될 예정이고요. 영어가 진행되고 나서 저희가 최대한 빨리 준비해서 번역을 해서 올려드리도록 하겠습니다. 저희가 진행하는 이 번역은 아마도 서브타이틀 형태로 진행이 될 예정이고요. 이 번역이 된 동영상은 저희 K 브랜드 엑스포인 smart-bizexpo.com 이라는 이름으로 들어올 예정입니다. 자, 그러면요. 지금부터 시작을 해볼까 합니다. 먼저 말씀드리는 내용 중에 영어로 진행되는 내용은 차후에 통역을 해드릴 예정이오니 많이 조금 더 기다려 주시면 감사하겠습니다. Okay, we are going to start our seminar with Mr. Dr. Graham Peaslee from the University of Notre, physics professor and the principal investigator of study. Dr. Graham, would you mind that you can start it?
Thank you for that kind introduction, and I apologize in advance. I don't speak Korean. I will speak in English as slowly as I can, and I hope that your translators will eventually be able to transcribe this. But I'm Graham Peaslee, and I'm at the University of Notre Dame, and I'm going to tell you about our study on fluorinated compounds in North American cosmetics. And as a quick outline for what I'm going to talk about, I have prepared a couple of slides here. Just, I need to describe what the fluorinated compounds of interest are. These are PFAS, per and polyfluorinated alkyl substances, and I'm going to give a few slides of introduction so that we are all on the same level to understand why these chemicals are of concern and why we wanted to study them in cosmetics to begin with. The health effects of PFAS and why they're in cosmetics and all the previous work to study them, and then what our work contributes. And then I will allow time for questions, and I hope that we can answer any that you have. So per and polyfluorinated alkyl substances is a very long and awful English sentence to describe this class of categories of chemicals that are all made around World War II, 1940s. They're all man-made, and it's a class of over 4,500 chemicals that all have a strange set of names. Some of them are called organofluorines, some of them are called perfluorinated compounds, or per or polyfluoroalkyl substances is the most recent name for the same class of compounds. And we like to refer to them as PFAS. This is the most broad name that encompasses all of them. They are amazing chemicals. They are able to produce surfactant properties that no other chemical can match. And they're used everywhere on textiles, carpets, papers, paints, cosmetics, and coatings. And they were also used as lubricants, oils, flame retardants, and solvents for other sort of chemical processes. They're used industrially widely. But also, as you can see in this capture of a video, they work very well. This poor gentleman had to stand in front of the camera and have mud thrown on them. And the gentleman on the right has had PFAS protection on his clothing, the one on the left, not so much. And so these compounds are well known. They've been around for 70 years. They all are common in one regard. They all contain a carbon-fluorine bond. This is just a little chemistry, and I apologize, we have to discuss a little chemistry first, but then we understand why these chemicals are important and why we need to look for them. And they are in all sorts of structures. There are 4,500 structures known. This is just 7 of them here. And they are all characterized by this carbon fluorine, the gray to the green boxes. There are carbon fluorine bonds. And they have acronyms that stand for each of these compounds. What makes them so good? Why are they such an incredibly powerful chemical that we use them all the time? And it's defined by that bond energy. This carbon fluorine bond right here has the highest bond energy of any chemical bond, single bond. And that means that they are very strong and that they will have tremendous properties of taking an end that likes water to an end that doesn't like water, and they'll line up along any water-air interface. This is the property that makes them a good soap or a surfactant. They're an excellent soap. Because of these properties, they have incredible water resistance, and that means that when we apply them to such things as non-stick coatings on cookware. That's why the Teflon that you put on a cookware. They're applied to carpets. They're applied to textiles, all the Gore-Tex jackets that prevent rain. They're applied to firefighting foams, and even microwave popcorn bags, food packaging. And this is a very often asked question: why would you put this on food? Well, you don't. But when the popcorn pops, you release water, and you don't want the water to go through the paper bag, so they coat the coating of this. And this is of concern because you've got a man-made chemical that likes butter inside a bag at 200 degrees with butter, and then you eat it. It's probably not the best place to put our man-made chemicals. But as for this talk, I would like to talk more about the cosmetic industry. And the cosmetic industry has discovered the miraculous properties of PFAS, and they have been used. And so what we do with this is that they provide ways to emollients that would divide these things, dispersants that would make these things evenly apply. It would make them waterproof, all sorts of wonderful properties you could put in cosmetics. So what's the problem? If this is such a remarkably good chemical, why wouldn't we use it? Well, the carbon fluorine bond is very hard to break. And that's both its good part, but also the reason it's bad. These chemical compounds, when they are produced, last for hundreds, if not thousands of years before they break or go away. There are no known animals or microbes that will eat this, or no abiotic, even physical chemical processes that will degrade them. So these chemicals last for an incredibly long time, and it's in English is called environmental persistence. These are given the nickname the forever chemicals. Once these chemicals are made, they last forever. And that is its biggest concern. Not the only concern, but that's its biggest concern. Because they don't degrade, these chemicals will be produced in a factory, they'll be put into waste, they'll be maybe in the air transport, but they'll be made into objects which also go to landfill. These landfills will enter the surface water, and the PFASs remain after all that, and they can be applied to crops and eaten. They can be drunk directly. They can be used on firefighting foams, which also get into animals, which also get into people. And so this process of keeping these chemicals around for thousands of years means that they cycle through the system. And most alarmingly in the United States is the fact that all these sources will end up in drinking water. This is true also in Korea. It's just a matter of how aware we are of what we are drinking. The advisory the EPA has put out in the United States is 70 parts per trillion, and that is a very, very small number. So this is one of the lowest requirements that we've had on any compound we put in the water. You can put up to 8 parts per billion of lead in water, and that meets the limit. But when you go down to 70 parts per trillion, that means these chemicals have been observed to cause health effects at much lower concentrations. These chemicals both bioaccumulate and biomagnify. These are words that mean that a little bit of chemical adds up in the animals. So if an animal is exposed to it at this level, and the fish eat it, and the seals eat the fish, and the bears eat the seals, if you look in the blood of polar bears, you'll find that there are studies that show that the polar bears have 88 parts per billion, a very measurable amount in normal polar bear blood. And yet the polar bear doesn't wear any clothing, nor cook with any cookware, or uses firefighting foams for that much. It's getting all its PFAS from the global transport of these chemicals around the world into the ocean currents, into the seas where the fish eat them, and where they're migrated to the northern pole, where you get the most magnification. All humans get their PFAS from what they eat and what they drink and what they wear. And all humans in North America, for example, have an average blood level of about 5 parts per billion. And this is an artificial chemical. We're born with this amount, in fact, if we have a mother that lives in this country. So these levels are a concern because why? Well, there was an event back in 12 years ago where a cancer cluster was discovered downstream from a chemical plant that made these chemicals. And they was a terrible ordeal, but 69,000 people were tested in their blood in this town of Little Hocking, West Virginia. And they discovered that after 8 more years of a very long study called the C8 Sinus panel, they discovered that there are 2 types of cancer, testicular and kidney cancer, 2 types of hypertension, the pregnancy-induced hypertension and hypertension, and then 2 other diseases, high cholesterol or ulcerative colitis, an autoimmune disease. So these diseases were found positively correlated. It led to a tremendous amount of lawsuits and then also an incredibly large settlement, which has repeated itself already several times now in several states in the United States. And this is because of the drinking water contamination. What does this mean to the cosmetics industry? Well, this is the introduction as to why PFAS are important, why they're used so widely. But then there's public perception. And this is what the public now knows about the chemical industry that created these chemicals. These chemicals don't go away. They persist in our blood, and they're making people sick. There are a documentary, which is very negative, and then a Hollywood movie, which was very popular, which is even more negative and shows actually what happened in the chemical companies' drive to make these chemicals. So the public perception is already very highly alert. And the United States is becoming very keenly aware of this. If you look at the number of publications, this is international publications no less. If you look for anything that had PFAS or PFC back in the 1990s, there were maybe 2 or 3 papers a year being published. Last year in 2020, we had over 600 scientific papers published recognizing the human health implications of PFAS, including liver malfunction, thyroid disease, hormone disorders, obesity, low birth weight, and this is an important one, immune system reduction. These are immunotoxins. They affect the immune system, and as a result, poor COVID outcomes. So why would we care about these chemicals now? Well, I'm going to give just a couple of examples of how complicated this chemical and how it gets into humans and why people are concerned about it. The first example is a paper that was published in January of this year about COVID, and a lot of people are very concerned about COVID. But what does COVID have to do with PFAS? Well, here's a study done by Philip Grandjean at Harvard, who has looked at the severity of COVID-19 in Danish patients, early COVID Danish patients. And there were about 240 patients that early on contracted COVID in Denmark. About 3/4 of them had no really serious illness and got sick for a few days and went back to work. About 1/4 of them were so sick they went to the hospital and were intubated. They had a tube in their mouth, and of those, many died. And so if you were in this intubation and death period, we look at what happens, and here are males and females. This was what happens as a function of one of the chemicals, the C4 PFAS. And if you had very low levels of this in your blood at 0.2 or 0.3, and the same units we had just in the previous start of where everybody has 5. This left in a short hospitalization, longer hospitalization, had higher levels, and those that were in intensive care or died had the highest concentrations of this particular PFAS. And this PFAS is the one that everybody says is safe. If you listen to the chemical companies, they say, oh, well, we don't use the bad PFAS anymore, we use only the good ones. Well, these are the good ones. And what they are doing is they're a surfactant, a soap that makes its way to the lung as you try to expel it, and then your lung capacity is reduced. And when you have a respiratory disease, which nobody knew about 3 years ago, COVID was new, then that respiratory disease leads to poor outcomes. And this is correlated with the presence of PFAS in your blood. A second example I'll give is one that's more well known. This is in firefighters. Firefighters use these chemicals as a flame retardant, and they use it quite regularly. And as they use the foam, they were told it was perfectly safe. So they get exposed to it. They don't wash their hands as enough as they should. And this is a series of data from Australia, a woman in Australia who did a study on over 691 South Australian firefighters, and took the blood of 699 South Australian firefighters and looked for the presence of these chemicals. The average in that unit was 12 parts per billion. Okay, a normal population in the US would be about 4. So it's about 3 times elevated from the normal population as a firefighter, because they're occupationally exposed to these chemicals. They have to use the fires and put fires out with foam. So these population, here's a scale of 200. Some of them had 100, 200, 300, 400. And then there's this one gentleman way up here who happens to be a Korean Australian, actually, who had a whopping, what was that, 1,600 parts per billion in his blood. And so this gentleman was interviewed. This was a survey done of all the firefighters. They went out and found this firefighter and asked if he'd been, drinking the foam or something. No, he hadn't actually used foam in many years and had only trained with it once or twice, had never actually used it. But he lived in the fire station for a week and then was 2 weeks off. In the fire station for 1 week, 2 weeks off. It was a suburban fire station. And what they were doing is they were cooking for themselves and exercising. So he was exercising to become a stronger firefighter. He was building up muscle protein with weightlifting, and he was eating a high protein diet, lots of eggs, 5 eggs a day. The egg yolks he was getting were organic. They were raised in chickens at the fire station, and they were cooked in a good way in an organic fashion, and they were fed only grain that was raised at the fire station. So it was all natural. Unfortunately, the grain was raised next to the pit where they tested the firefighting foam. It got into the soil. The grain absorbed the PFAS. The PFAS was eaten in the grain by the chickens. The chickens laid eggs, and it bioaccumulates in the egg yolks to about 1,800 per billion. And this begins to look very much like since he ate so many eggs per day, the PFAS had bioaccumulated into this one firefighter far worse than anybody else. So why do I tell this story? Well, is that a case of poisoning by AFFF, the firefighting foam? Yes, but it's not because he was using it occupationally. It's because it got into the food that was put into the chicken, that he ate the chicken egg, and then he got the poisoning. So are there any plants used in cosmetics? Could they have also been exposed to PFAS from a firefighting foam completely unrelated? Absolutely. So there are all sorts of ways these chemicals can get into products that we don't know about. They're also intentionally used. And by exposing the population to these chemicals, we risk an exposure of some of these chemicals in the blood. So why am I studying this? How does a physicist in the middle of the Midwest of the United States study perfluorinated chemicals? Well, this is our only one slide of promotion here. We have developed a method by which we can analyze quickly the presence of fluorine, and it requires an accelerator. It requires an accelerated beam of particles. We put them onto a target wheel in air, and we can measure very quickly whether it's a popcorn bag or a copier paper which has no fluorine, or a popcorn bag which has fluorine. We get a very rapid signature. It only takes 3 minutes, and in 3 minutes I can identify the bag as fluorinated, not fluorinated. The same thing can be done with other products. It's very rapid, it's non-destructive. And so this technique, for several years now, we've been publishing that we look at papers and textiles, and we say this method finds all the fluorine from, it's called PIGGY, the name of the method. This finds all the fluorine. And when you look with the traditional chemical methods, you find only 1 or 2%. So we find 50 to 100 times more fluorine than people that look for PFAS. But it's all PFAS, especially in papers and textiles. There are nothing but PFAS in there. And so we see a lot more PFAS than there are in the environment. And the reason is that this is the chemical that perhaps is made, but then in the environment, it decays into the more stable form, this PFAS, after several transformations. And each of these products lives for a couple hours or a couple days, but none of them are measured. You either measure this one or you measure that one at the end. And when you measure this one, it stays for thousands of years. So if this were to get in your blood, then your liver would turn it into this chemical, which would stay in your blood for maybe 5 years. Or this one's about 3 years. And so that's why these chemicals are a little worrisome, because they last in your system for so long. Our technique can be compared to other techniques, and I just use this to show that this is a new technique nobody had seen before, but we measure all of it. And I think it's important to measure all of it, this total fluorine screening, because while the traditional method is very sensitive and can measure to part per trillion, it's very expensive. And it only sees about 1%. And there's a couple of studies out of Sweden and other places that shows that how much organofluorine are we missing? Maybe 99%. So this problem in the United States is now being recognized as being much larger than what we see in the drinking water. We measure only 1% of what's in the drinking water, and there's maybe 99% left to go, which suggests that this poisoning could be a lot larger than anybody thought. We used this technique once before, several times before now, but we published a paper back in 2017, which was on U.S. food packaging, fluorinated compounds in U.S. food packaging. And this paper was very popular. We have over 32,000 downloads. It was one of the biggest papers we'd had at that time in this journal. And it was all the famous companies that used it in their food packaging. We reported that about 1/3 to 40% of the food packaging had fluorinated chemicals in use. And within 2 years, every single one of these companies, Panera, Starbucks, McDonald's, all these famous companies, they just removed it. They said, it's only on the wrapper, it's not in the French fry. But the concern was that it gets to the French fry, somebody eats it, or more importantly, that French fry wrapper gets put into the landfill and we drink it later on. 100% of the chemicals will come off in the landfill. And that was the concern there. And so with this example where we already did a study and it affected the industry rather significantly, I'd like to talk about cosmetics, and I'll spend just the rest of my time talking about PFAS and cosmetics. Now that we know what PFAS are, and the fact that they will be produced and then end up in both the waste products or in the humans, or the environment, it can get into the environment as well. The question is, why would it be in there? And this is a remarkable property in the sense that these form films, and they are very hydrophobic. They don't like water. So that means that they would be resistant to smudging and staining and water. So if you want to waterproof something, this is a chemical that's often used. And there have been studies before, these 3 studies listed right here in 2013 in Asia, that's in Japan, to these 2 studies in Europe that came about. And between those 3 studies, they studied about 72 different cosmetics or personal care products that had on the label a fluorochemical, both in the Asian market for the first one and the European markets for the other 2. So nobody had studied North America. And these studies were measured to identify what was there, and then also to measure how widespread they were used. And they only chose, these are the literature for these 3 studies, they only chose for these 72 products something that said on the label that it was contained a fluorochemical, i.e. a PFAS. And so they took these ones out, measured it. They found some chemicals that weren't on the label, but most of them were labeled, and they found what they expected to see. So then we realized this article came out in 2018. We read it and said, gee, I wonder if we've ever done that in North America. And so we should do the study in North America. And of course, we had a different technique that was spectroscopic, i.e. very quick. And so we could go through a lot more samples than 72. We published this paper 1 month ago, and this is in June. And just for reference, this has had 61,000 downloads in 1 month. This is the largest number of downloads that this journal has ever had for an article. And this is one of the top environmental science, this is the top environmental science technology journal in the American Chemical Society. So we've now rocketed to a lot of news coverage. There's 331 different news stories. We made Reddit, the front page of Reddit for a day. That was pretty impressive. And we have lots of reporters calling to ask, because this hits the consumer very strongly. And they wanted to know which brands, and we deliberately didn't say which brands. We told them that we measured all brands, and all of them had fluorination in it. Here we see some of the fluorinated categories of where we found them, but particularly in the lips and the eyes and the foundation, we found over 50% of the compounds in that area, or on average, about 40 to 50% of the compounds had high levels of fluorine. Now, there is some confusion because fluorine doesn't just mean PFAS, it could be inorganic fluoride. So we had to measure that a little bit further to see which was which. We broke them into categories of lips and foundations and eyes and mascara, what other types of facial products, concealer, eyebrow, and miscellaneous. And we focus in on two in our more specific study, because these two of lip products and mascara products for the eyelash were focused. We had 231 products total, so that was a good sampling, but not complete by any means. We did all of these. We did skincare, lipsticks, liquid lipsticks, eye makeup, foundation, and we put them on. You can see some of the brightly colored ones on the wheel that the student mounts, and then we measure. And we found this amount of fluorine, high fluorine, moderate fluorine, or low fluorine in all these items. And in some categories, like the lipsticks, we found a very high percentage of them being fluorinated. Then we took a subset with only 29 of these, and we extracted and looked for the specific PFAS. We just measured fluoride to see with the presence and absence. We screened it to find the highly fluorinated ones, and then we looked at that. And we did some low fluorinated ones to see what we found. And in both the US and the Canadian products, we see that there are some very highly fluorinated ones. These are all very highly fluorinated. These are all very highly fluorinated. And then we see some which are low, and there are several here which are low. And that means there is, in every product we looked at, there was fluorine, and in fact PFAS. These are identified PFAS in foundations, lipsticks, and mascaras. Sometimes very large quantities of it. This one is very large quantity here on this foundation. These ones were lipsticks, and then on the waterproof mascaras. Several of the waterproof mascaras were quite high. All 29 products contain PFAS. And the number of each PFAS was detected. There was between 4 and 13 different types of PFAS detected when we started to look for them specifically. If I were to look at them by individual compounds, you'd see things that show whether they are fluorotelmer alcohols, which is a new category that hadn't been defined before, but we found that some of them were very heavily done that way. Some of them were on these things called methacrylates, which was again a new, that had been seen before, but we see that it's more widely used. And we also have found what we think is some of the inorganic fluoride. We found some synthetic clays or minerals, natural clays that were there that would contain inorganic fluoride. But we also found literature to some industrial information that suggests these colorants and acrylates and synthetic mica is being used with PFAS in them. And then there are some other compounds which weren't listed as for fluorinated, but we suspect, looking at patent applications and things like that, that some of these compounds are being used as well. And so the shocking part for us was that in the United States, none of the 29 analyzed had any PFAS on the ingredient list. I take that back. One of them had Teflon listed, but it was only one of the 29. So of those 231, there were several that had PFAS listed, but they also, as an example of how confusing this be, they have clays and talcs which could be inorganic, but synthetic mica is a natural mineral, but they can add PFAS to it to make it last longer. It gives that beautiful iridescent glow. And so we felt that of these wonderful compounds, that there would be a serious need to revisit the labeling because the labels did not contain anything the consumer could find that says they had PFAS intentionally added to these products. And looking back at the data, not necessarily all the products were intentional. I would say that these ones had to be intentional. When you get down to these ones, maybe that's unintentional. Maybe that's just an impurity in the chemical supplies. We don't know for sure, but when you have this much added, it was added intentionally. And the labeling does not show that. So what did we look for? We looked in the literature for what could be there. And we find these available tinctures, pigments, and things like that that are made with fluorinated compounds in them, PFAS. We found fluorosilicones available as have broad solubility characteristics, a solvent that you could put in there. gives you a satiny skin feel. We found side chain fluoropolymers and fluorinated polyethers like PEG-10, which is made with a perfluorinated compound, but PEG-10 can also be made without the fluorinated compound. And so the labeling that just says PEG-10 does not necessarily mean that it's fluorinated, but in some cases we believe that it is. And where we're going with this is that there is a direct route of exposure for these chemicals directly through the tear duct or through accidental ingestion or inhalation, or even skin absorption, where these things could get into the bloodstream directly from the user of these cosmetics. But more importantly, the cosmetics are not all used on the face. A good fraction of the mascaras and the liquid lipsticks, for example, may wear off and may in fact be left and thrown out into the landfill. These landfill products will get into the drinking water, and that means even people not wearing these cosmetics will end up drinking the product because this chemical doesn't go away for thousands of years. It will go through the landfill leachate and will be drunk by other people. So this is our concern. We have found a source of exposure to in the US and in Canada that had been reported before in Europe and in Japan, but we know now that it doesn't obey the labeling that we come to expect of our compounds, that we'd expect it to be labeled. And this is of concern. So we report this, we had it peer reviewed, we can now be reproduced by anybody else. We've shown the methods by which we measure this. And there are lots of labs in the world right now out measuring this to see where they are. I believe that it isn't the end of business as we know it, of course not. This is a chemical of concern, and that several proactive companies will get in front of this and say, oh, well, I could look at my supply chain a little bit better and make sure that we don't accidentally use these chemicals when we can have other alternatives. The good news is that there's 50% of the chemicals that use this, 50% of the cosmetics we studied use these chemicals, but there's also 50% that don't, maybe more. And so that means that there are non-fluorinated alternatives available. And if the consumer were to be shown which products did not have fluorinated compounds, or if a label were created that says no intentional use of PFAS, there would be a market advantage to producing chemicals that don't have these forever chemicals in them, and these cosmetics that don't have forever chemicals in them. And so that's my object message here, to talk to cosmetic companies around the world and say that these products were perhaps sold as being perfectly safe. They're not. We may not have been told at all that they're there. You may have actually found them in the supply chain by accident. And even in the ones that didn't use them intentionally, there seem to be small amounts coming through, which is likely to be, oh, it's just one of the trace ingredients that you used, only a few % of this. Perhaps it doesn't need to be on the label, but it's producing a lot of these chemical, the PFAS that get into the measurements. And so now that we've reported this, I think other people will begin to examine and look at their processes. We'll study more of these, of course, as time goes along. But I think everybody will go back and say, gee, I wonder if this is in my cosmetic. And at the moment, the labeling in North America isn't satisfactory for the consumer to understand whether it has or has not. Predominantly things that are waterproof or that say long-lasting are the ones, or the more expensive ones, because fluorochemicals cost more. The more expensive products that say long-lasting or waterproof tend to be the ones where we found the PFAS at very high levels intentionally used. Now, there will be several cosmetics and personal care products that don't use PFAS, and people will discover those and start making lists of these chemical compounds. But I think the industry could get way ahead of this and simply, like the fast food industries before them, decide that this chemical isn't necessary. I can make something equally as palatable or equally as colorful or as equally long-lasting or at least safer by making it without these fluorochemicals, and they can advertise that. There is in the United States now a line of surface cookware that says no PFAS used in its construction, and that cookware is being bought. Excuse me. That cookware is being purchased by consumers that are looking for something that's PFAS free. I'm running out of voice here at the end of a long day. I'm sorry. I apologize for that. I'd like to acknowledge the funding we got some funding from Canada, Environment Canada, and the Research Council of Canada. We also got some NSF funding to employ our students in this. And we have undoubtedly many people who watch this that aren't able to answer questions right now. So I've included my email address here, and I would be happy to talk with people. The object of my story is not to insult any of the manufacturers or but to show them the opportunity that exists in addition to the threat that exists. There's always going to be lawyers involved that will try to change laws and try to rectify the situation. Why I think there's a real opportunity for companies to take a look and actually do some testing on their own and make sure that their products are in fact PFAS free. And this will allow companies to have a competitive advantage. And I hope that that's the message I can convey. I thank you very much for your attention, and I'd be happy to answer questions.
Dr. Peaslee, thank you so much. It was a great class and seminar, but I hope some of the manufacturers or attendees not bother this issues, but it's really great to know about that accumulation in our body. So from now on, so Miss Leslie, our advisory board member, will join as an MC for our Q&A session. Miss Leslie?
Professor Peaslee, first of all, on behalf of the board of directors, I can't thank you enough. We've been following you on Google, and we see that you're in hot demand all around the country right now. So we really feel privileged that you were so accessible and so willing to speak to our Korean manufacturers and U.S. retailers. It says a lot about the integrity of your study and your real desire to make a difference. Thank you for that.
I thank you for the opportunity. I mean, to speak to a manufacturer is very important to me because I believe that they, 9 out of 10 of the manufacturers are going to really want to do the right thing for their customers and really do the right thing for their industry. And I think this is an opportunity to tell people that have the decision to make. And I think this is a real opportunity to look for a positive aspect to something that could otherwise be interpreted as, oh my gosh, here's a change coming, a threat. And this is really an opportunity, and I'd like to present it as that and help answer questions if I can.
Actually, Professor, it is that. What we've been hearing from U.S. retailers is that it is an opportunity for us to, our manufacturers, to put forth clean, healthy products because they have an obligation to the consumer. So we heard a lot of that in this session. So I think that's the positive, and I like the word opportunity that you presented because that is an opportunity for us. Now, of course, on behalf of our manufacturers, we're going to be watching Congress to see, what impact your study has on the way they're going to regulate the FDA. And we just had Kim Scarborough, chief chemist for color and cosmetics on, and she couldn't obviously comment on what Congress was going to do, but we do see that your study is going to have an impact on the way Congress looks at some of these issues at the FDA. So we thank you for the warning, and we're going to, our manufacturers are going to look at this as an opportunity. Professor, some of the comments are actually in Korean, and I can't read them, but we're going to follow up with you on email because you have been so accessible, and we support what you're doing, and we hope to play an important role in making some of these corrections.
Very good. It's an opportunity, and I think I can't tell what Congress is going to do either. The paper wasn't intended for Congress, but people take this very seriously. The people in Congress wear cosmetics. The people in the news industry wears cosmetics. So the 9 out of 10 reporters that called me all said, "What about brand X?" And they told something up, and I was like, "I don't know about brand X." And so I think that people, when they're touched personally by some story that shows, this is not a good product to be out there with this chemical in it, and there are products that don't have this chemical, well, they want to know which one is which. And we deliberately didn't do a broad enough study to decide that. Every chemical company we looked at, every cosmetic company we looked at, had some brands that were PFAS rich and some that were PFAS poor. So it didn't seem to be uniform, but it seemed to be much more common in some areas, like the waterproof mascaras and the liquid lips. Those were the two areas we saw the most of them. Foundations also had a lot of PFAS in them. And so I think these are areas where the industry could look and say, gee, how did that slip past us? Why did we think that was a good chemical to use there? And perhaps it has, maybe it's a very good surfactant. You need that there, but you'll have to argue with the consumer whether they want that there. And I think that this is an opportunity to come out and, the labeling is going to take years to straighten out in Congress. If you wait for Congress to straighten out the labeling, it may not work out in your favor at all, and it may not. But if you add the simple words, no intentional PFAS used, and you can prove that, you have somebody tests it and says there's no PFAS in there, then you are, I think, way ahead of where the rest of the world will be. And that's a good opportunity. And so I mentioned that just as, if you wait for the labeling laws to change, I can predict I'll hopefully still be alive when the time that happens. It's going to take many years to do that. But I think that the market demand will already be very quick, and people will say, gee, I have an alternative of this or that. I'll take the one without the PFAS. And I can already hear that from customers and news reporters that ask me. I'd buy the non-perfluorinated one, but I really like this product better. Yes, that's true. But I can't tell you which product is which. All I can say is that we looked at all the chemical companies, and we're not trying to take shots at the industry. We're trying to alert the industry to a problem they probably didn't know that was there. I don't think the industry tries to put this stuff in intentionally. I think it is, they were told it was safe, so we use it. And it's really the fault of the original producer that says this is safe, safe, safe. And we don't find it to be that safe. And there's lots of evidence now that these chemicals, this entire class of chemicals is pretty unsafe.
Well, that's terrific. And hopefully by next year, some of our manufacturers can be citing your study and how they made some changes as they present to retailers around the world about the healthy ingredients in Korean products. So thank you so much, Professor.
Do you mind that I can ask my question, if you don't mind, Miss Leslie?
Yes,
Sure.
I'll turn it over to you, Daniel.
Okay.
Well, which cosmetics do you wear? I'm sorry.
Okay, listening from your studies, I don't know, it's a stupid question, but I have two questions comes out to my mind. So, in all this study, did you get anything, find out for the alternatives?
Did we look at the other chemicals being used? All I know is that I found that at least half the chemicals had no fluorine, no significant fluorine, and that means that they were not using a fluorinated product. And that means that there must be alternatives out there. Probably a lot of silicones and things like that are not dangerous, we think. And so there's certainly lots of products that are being used that are very natural and very safe in a measure. But then there are chemicals added. Some of them are colorants, some of them are dispersants, some of them are part of the foundation of what we use in the cosmetic. And I don't know all their functions. But we were just looking for this one particular class of chemicals because of our experience with it and how to measure it. And we had found it in food packaging, we'd found it in textiles, and we're still finding it in other products too. But cosmetics seem to be a pretty easy one to find. And there are reasons why you might like it if you climb Mount Everest. But if you go to the mall, does your clothing need to be waterproof? And when you get to the cosmetics industry, does it need to be fluorinated? And that's why we picked on this particular chemical. We weren't picking on the industry. We're picking on this chemical and say, look, if we can stop the use of this chemical, generations of people after us will be much healthier. And this is because it gets to all of us. And so that's the first one. We sourced plenty of them that didn't have PFAS, which we would call safer. We didn't look for other chemicals that might be, nobody's using mercury anymore. That's good. But we didn't see anything else that we weren't looking for other chemicals.
I see. Okay. So second question is, it's a more stupid, but so in this study, did you get anything about the flush out those accumulations?
That's not a stupid question at all. That's an excellent question, because people always ask, okay, now that it's there, what does it mean to me? If I've used this lipstick or I've used this mascara, what does it mean to me? It may mean nothing. If you never lick your lips and you never ingest any lipstick, then you're probably safe. But we know from other studies that people that put on lipstick often lick their lips, and then some of that material will be ingested accidentally. But that means that you have a chance for exposure. The quantities we see in there are very high. They're in part per billions, or hundreds of parts per billions, and even thousands of parts per billions in some case. And that means that even a small amount of that is more than what you have in your blood. So that's that means that it's of concern. It shouldn't be compared to drinking water levels, because you're not drinking mascara, or liquid licks. You are just wearing it. And some of it won't go into you. And again, it's statistical. Maybe some people can eat some and it doesn't matter, and other people eat some. Some people smoke their whole life and don't get cancer. Other people, smoke not at all and they still get cancer. So there's no statistical certainty with any of this. You can't prove your disease came from this. But what if some of these compounds were getting into people and causing disease?
Yes.
Wouldn't we like to just have the alternative where that wasn't the choice? And we know that now that children are getting born with over 200 products in their blood at newborns that were artificial chemicals. These are all artificial chemicals. And if they're showing up in the blood of newborns, how did they get there? And so this is just one source of exposure. And we think it's one that's very amenable to change. I think there's alternatives that are safe, that doesn't destroy the industry. The industry will still survive just fine. My paper isn't going to do anything to that. In fact, if it grows and becomes a healthier cosmetic, then I guess the sales will go up. And that would be good. And so I think that this is just alerting people to the fact that this chemical, for many years we were told it was safe, and it isn't. And that's the issue. And so the chemical industry does a wonderful service in general, but on this compound, no, not so good with PFAS. And it's a wonderful material and very profitable, but it lasts forever. And so imagine making a product that would never go away. How do you argue sustainability or safety with that? And that's the real issue.
Thank you so much, sir. It's really good class for me. Okay.
You're gonna cut down on that lipstick from now on, I can tell.
I think I should send some email to you with some more questions.
Very good. I'd be happy to do that.
Worse than the other one. So thank you so much. Miss Leslie, would you like to say something to us? Okay, I think that she's not in there. Okay, we are about time to wrap it up, this seminar. It was so good to talk to you, and also it is a great seminar to us. And thank you for all attendees. Thank you so much. It was a great seminar. I hope you guys enjoyed this seminar. And then you can watch this video clip from our website, smart-beesexpo.com. Thank you so much. Have a good
thank
night.
you, Daniel, Professor.
Thank you, Leslie. Thank you very much, Daniel.